Hey guys, we're going to start our lesson over finding area of regular polygons today, day 1. We are spending 2 days on this lesson because it is so important. So let's go ahead and get started. Regular polygons, we learned this when we did our polygon unit. Regular polygons simply mean that polygons that have both that are both equilateral which just means that all of the sides are congruent to each other. So this pentagon, all those sides are congruent. That triangle, all those sides are congruent. And this is a square because all 4 sides are congruent. So it's both equilateral and equiangular, which means all the angles are congruent. And if you take a look at this, they can be perfectly placed within a circle. So each one of the vertices touch the edge of the circle. Okay, a couple things you need to know about regular polygons. There is something called a central angle inside of a polygon. A central angle comes from the center and it connects to each vertice. So that right there, it's not perfect because I'm drawing it, but that right there is the central angle of this pentagon. Okay, so there are 5 central angles within the pentagon. 1, 2, 3, 4, 5. So in this unit, we're going to have to understand what is a central angle. So each one of these are central angles. So how are we going to know what each one of those measures? Well, as you can tell, it makes a 360, goes around a circle 360 degrees. So to find a central angle, we just do 360 divided by n, divided by how many sides there are. Well, in this case, there are 5 sides in Pentagon, so 360 divided by 5. We can go to our calculator. 360 divided by 5 is 72 degrees. So each one of these angles is 72 degrees. Okay. There's also something else that's really, really important that we need to know what it is. It's called an apothem, and it's a word that you may never have used before or heard before. A-P-O-T-H-E-M. Apothem. And the apothem is simply from the center where all of these angles start, but instead of going to the vertice, it goes from the center to the midpoint of each side. So these are all apothems. And we're going to be using those in this unit. Okay, so this right here is an apothem. So as you notice, the apothem cuts the central angle in half. So this would be half of 72, and this would be half of 72. Okay, let's move on. Okay, find the central angle of the following shapes. Regular pentagon. Actually, we just did that. 360 divided by 5, and your central angle is 72. Okay, regular hexagon. 360. Remember the central angle, 360 degrees all the way around, so we have to cut it by how many sides there are. 360, a hexagon has 6 sides. So 360 divided by 6 is 60, I believe. Okay. And the central angle of a regular triangle. So 360 divided by, triangle has 3 sides. So 360 divided by 3. 120 degrees. The central angle of a triangle is 120 degrees. Okay, really important that we know how to find the central angle. It's just 360 divided by the side lengths. Okay, how can I find the area of a regular polygon? Okay, any shape. It could be a square, it could be a equilateral triangle, it could be a regular pentagon, it could be a regular hexagon. And I'm going to go ahead and just tell you what the formula is that we will be using to find the area of a regular polygon. It is area equals 1/2 of the apothem, little a for apothem, times the perimeter. Okay, so little a again stands for the apothem, which, remember, this guy right here, this dotted line goes from the center to the midpoint of the edge. That's an apothem. So right there, that would be an apothem. That would be an apothem. So from this blank pentagon, from the center to the center of the edge would be the apothem. And then the perimeter, or the big P, just stands for perimeter of your shape, which is simply the distance around the shape. So this side plus this side plus this side plus this side plus this side equals your perimeter. So this will be the formula that we are going to be working with when we are finding area of a regular polygon. Okay, let's go ahead and look at our second example here. We have it appears to be a hexagon, 6 sides. Find the area of a regular hexagon with an apothem of 5 square root of 3. Okay, so let's draw our apothem from the center to the midpoint of an edge. And let's label that as 5 square root of 3. And its side length, so each side length of our hexagon is 10. So all of these are 10. So we can find the perimeter really easily. 10 plus 10 plus 10 plus 10 plus all the way 6 times. Obviously 10 times 6. Your perimeter is going to be 60 inches. And your apothem is 5 square root of 3. So we're going to go ahead and use our new formula we just learned. Area is equal to 1/2 of the apothem times the perimeter. And then plug in what we've got. 1/2 times the apothem, which is 5 square root of 3, times your perimeter, which is 60. Okay, we can plug all of that into our calculator. I'm just going to use 0.5 as our half, times our apothem, which is 5 square root of 3, so second x squared, and then our 3, and then arrow to the right so that we're not underneath the radical sign anymore, and then times our perimeter, which was 60. And in this, in these lessons, we're going to be rounding a lot to the nearest hundredths place, which is 2 decimal places, so 259.80, but the 7 rounds the 0 up to 1, so 0.81. So we have 259.81, and then we're measuring in inches, and since it's area, it's inches squared. Okay, let's move on to example number 3. Okay, on example 3, we see we have a square as our regular shape, and we're going to find the area of the square with both the new formula, 1/2 a times, so 1/2 apothem times perimeter, 1/2 a times p, and we're also going to use our regular formula that we know how to use, area equals side times side, or side squared. And I'm going to show you that it comes out the same either way we do it. Okay, so find the area of the square with apothem of 3 by using a equals 1/2 a times p. Okay, so let's draw our apothem first. Remember, the apothem comes from the center to the midpoint of an edge. We're going to label that as 3 in this case. It's an ugly 3. Let's redo that. There we go. Okay, and we're not given any other information besides this. So this is where our central angle comes in. Remember, the central angle is 360 divided by how many sides there are. Well, a square has 4 sides. 360 divided by 4 is 90 degrees. So when we draw our central angle, which remember goes from the center to each vertex, so that central angle right there, this whole thing right here is 90 degrees. Okay, but as you see, the apothem cuts that angle in half. So really, this angle here is 45 and this angle here is 45, because 90 divided by 2 is 45. So really, I'm going to redraw Okay, so this is this triangle here. I've just redrawn it. Your apothem is 3. So this angle right here is 45. And we also know that all the angles of a square are 45. So really what it's doing is it's cutting that angle in half as well. So that angle, because of this side length of our central angle, is cutting the 90-degree angle in half. So we have a 45, 45, 90-degree triangle right here and right here. So if this side length is 3, which is across from our 45, remember 45, 45, 90 is x, x, x square root of 2. We know our x is 3, our other x is 3, and our hypotenuse is 3 square root of 2. So our side lengths here are 3 and 3, and our hypotenuse is 3 square root of 2. Well, what are we trying to look for here? We have the apothem, which is 3. We're looking for the perimeter, or the distance around our square. So we know that this guy right here is also a 3 because of our triangle. So that means that this guy right here has to be a 3 as well because it cuts at the midpoint. So our whole side length here of our square is 6. So each one of our sides of our square is 6. So that makes our perimeter 6 plus 6 plus 6 plus 6, which is, or you could say 6 times 4, which is 24. So now we have all the information we need to plug into our formula. 1/2 of our apothem, which is 3, times our perimeter, 24. Let's go to our calculator. 0.5 times 3 times 24 is 36. And we're measuring in centimeters, so 36 centimeters squared. Okay, well, let's see if we can match that with area equals side squared. Well, we already know from what we've done over here what each of our sides are. Okay, we found out over here that each of our sides is 6. So, in using our regular formula that you would usually use with a square, side squared, and each one of our sides is 6, and 6 squared is 36 centimeters squared. So, as you can see, you can either use 1/2 a times p or side squared to find the area of a square, and you will get the same answer. Okay, this last example we're going to do, example 4, is extremely important. So I want you guys to really pay attention on this example. This is no longer a simple shape that we're used to working with, like a equilateral triangle or square. This is a regular octagon, and notice we don't have a picture. When we don't have a picture, I simply just make part of the octagon. Something looks like that. It could be any shape. It could be a hexagon or a pentagon, but this is just part of our octagon. If I kept building it around, it would be an octagon. And we're going to go ahead and label that this has an apothem of 8 centimeters. So from the center down is 8. So I'm just going to pretend like that's the center right there, and I'm going to label this as an apothem of 8. Okay, so from this point, remember up here when we had this situation, we found the apothem, the first thing we did after that was find the central angle. So we need to do that here as well. The central angle, again, is 360 divided by how many sides there are, which are 8 sides, because an octagon has 8 sides. Whoops. So 360 divided by 8 is 45. So the central angle of a octagon is 45 degrees. So let's make our central angle. Okay, not perfect, but looks pretty good. So this whole thing here is 45 degrees. The problem is the apothem is cutting that 45 degrees in half. So if I were to redraw just this right triangle right here, obviously it's not going to be perfect looking. Okay, so I'm redrawing just this guy right here. Our apothem is 8, and this would be half of 45, so it's that angle right there. Since the whole thing is 45, half of 45 is 22.5 degrees. So this guy right here is 22.5 degrees. Okay, and we also need to find the perimeter of our octagon in order to be able to fill in 1/2 of the apothem times the perimeter. The only thing that we're missing is the perimeter. So we need to figure out the lengths of our sides. Well, I know nothing about the length of my side. However, if we look, remember this triangle right here, it's just the same as this one right here. I just kind of moved it so I could relabel it. I'm looking for this guy, which is just half, because this is the midpoint, this is half of one of our sides. Well, you guys know trig, and you know that if we have an angle in one of our sides, we can find another side. So really, from our angle, we're looking for the opposite, and we have the adjacent. The apothem is the adjacent. It's right next to our angle. So really, opposite over adjacent is tangent. So you will be using trig here. Tangent of our angle, which is 22.5, is equal to, remember tan is just tan of our angle equals opposite over adjacent. So tan of 22.5 is equal to opposite is x over our adjacent is 8. And remember our little wrap, when x is up high, you multiply. So it is up high, so we multiply times 8 to get rid of the divided by 8. So this is a good time to check and make sure your calculator is in degree mode, and we're going to multiply 8 times tan of 22.5. Let's check that it's in degree mode. Hit mode, and you can see that mine has degree highlighted. So let's go back to our screen. So we are doing 8 times tangent of 22.5, and it'll give us half of our side length, which is 3.3137, blah, 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 blah. So we need to round. The 3 is not big enough to round the 1 up, so 3.31. Okay, so this side length right here, or half of side length, is 3.31. 3.31. Which would make the whole side length 3.31 times 2, because it's 2 of those. So 3.31 times 2 is 6.62. So each one of our side lengths of our octagon is 6.62. This is 3.31, this is 3.31, which makes the whole thing 6.62. So to find our perimeter, we're going to do 6.62 times the fact that there are 8 sides. So let's go to our calculator. 6.62 times 8 is 52.96 for our perimeter. So now we have everything we need to plug into our area formula. Area is equal to 1/2 of the apothem. Remember, our apothem was given to us, 8 centimeters, times our perimeter, which we now found was 52.96. Plug it in. 1/2 times 8 times 52.96. We have our area of our regular octagon, 211.84. 211.84, and we're measuring in centimeters squared. Okay, we're going to go ahead and leave this last problem for class, so I will see you guys tomorrow.